Interesting idea. Who were you able to share it with and get feedback, and who'd you talk to?
We shared it with Sophia, the archaeologist, and Alan the fabricator.
Okay. Tell me about the archaeologist and the feedback that, okay, I see that there.
Well, at first, she said that we were overcomplicating it because we were planning on having like fans, tubes,
Okay.
this stuff. But then she said that we were overcomplicating it and that we really just needed a sealed box that can protect the artifact. So then we changed it to this. And then we landed on this design. And yeah, that was kind of our final design.
Can you take out and show what you've been dropping?
Yeah.
Successfully?
An ancient Woodbury artifact.
Wow.
2 kits. Very nice.
Oh, that's great.
And there's no cracks or anything yet. No bottom or anything. Like no bend. Yeah.
So you've been doing some testing then,
Yes,
A lot of
lots of
testing.
and it sounds like the testing confirmed your thoughts about how the design should work. Were there any results that kind of surprised you? You didn't expect?
How the open cell phone gives more G-force than the closed cell phone because the phone measured the G-force of when it sprung back into the air.
Mm-hmm.
So it kind of was like acted like a trampoline. Well, this one it kind of just went like this instead of springing back up into the air.
Okay. That's good. Now, are you envisioning that the actual shipping container would be like that box itself? Or you're thinking,
Probably just like more robust box. Also, we also would like to put on a safe in it, which is we have an Arduino with a screen that shows all of the current variables in it. So it'll say like the average, the current temperature,
right?
the high and the low, using where is this sensor? Right here.
Yeah, bring it on over.
Okay.
So since regional, you guys have learned that
Yes.
new technology, and how did you divide up the work?
So basically every practice we would do some of this and then some of that, and then we would switch off. So we could still make progress on our other stuff.
We also found out that a regular this thingy, it's just a bunch of pieces of metal inserted into a plastic holes. So then all of these, if you add them like from here, they're all connected. If you added them from plus
Yeah.
with the minus, they'd be all connected because the wires come here.
So you guys all learned about breadboards.
Yeah.
You learned about how to program an Arduino.
Yes.
You learned about LEDs and current limiting resistors.
Yeah.
You learned about the power supplies and some coding.
Yeah.
How much AI did you have to use to get up to speed on that?
So the original project, which was
It was
a RFID reader, so you would scan the card,
Yeah.
and then it would say on a screen, it would say either if it was the right card, it would say, oh, this is, you are Los Excavadores, and if it was the wrong card, it would say that.
it would
So
say
that
access
project was
You
all
would know.
AI, the first one.
Yeah.
Since then, we have used YouTube tutorials like
code
the
with Connor.
Code with Connor, and that one, it didn't give you any copy paste, you would have to type it, so that means you know exactly what it is.
Okay.
And the most recent one, this one, we actually ended up coding a lot of it.
The
Use
code
it,
with Connor one,
we didn't use anything to come up with the math, and none of the parents told us how to do that, we just figured out how to do the average and this stuff. Just based on,
Nice work.
in between the AI one and this one, we use this temperature and humidity sensor, which is basically when you press a button, it was hooked up to this screen.
Yeah.
And then it would change, it would kind of like this. It would either change it from humidity to temperature. Well, this one, it automatically
So
changes.
let me ask you a question. How much of what you learned programming the Lego robot kind of made sense and you were able to use these concepts for this?
so it transitions well because we use for a robot a unique thing that kind of relates a lot to Python, so it went over well when we started
Sure.
working on this.
Sure, this is very, very transferable
Yeah.
coming from Python.
We also learned
Well,
about
it was like blocks that are like the same as Python.
the blocks which can translate into Python. We also learned about digital and analog. I think digital is on or off, so only 2 inputs, but then analog it has 1023. Why 1023?
Oh, you use the analog input.
Because
Sure.
zero is also an input.
So this side
So
would
it's
be
1023.
digital and this side is analog.
Got it.
And I like how you spoke to both an archaeologist and a packaging director. Were you able to go back with your solution and get feedback?
Yeah.
And what, after the sensor part as well?
No,
No.
after the sensor part, we didn't go back. So, also, it says, this is how we came to the idea. So it started with all of the kind of stages.
Can you bring that over?
So-
Take a closer look.
So we first started with all the stages, and then we figured out, we kind of decided that maybe some of the other teams would be doing this. So then we decided to kind of do shipping and handling, so we decided that, so we had all of the kind of ideas. So down here, we have the original design on the very bottom, the original planning. And on this side, we have more original designs. This is all of the materials we tested down on the second one right there. And then on the very bottom, there's just more testing materials. And down in the middle, that's just all of our problem state. That's just, how we can dive in more.
Okay, so let me ask you a question. What do archaeologists use today if they want to protect their artifacts with more than bubble wrap? Like, if they know something that's really important, what do they use?
Bubble wrap.
Yeah, probably. Yeah,
Bubble wrap.
I guess they don't really have.
Yeah,
Well,
they
so
don't have
the
a
archaeologist just said, we just bubble wrap it, put it in a box, and set it on. Yeah, and how the packaging director said, if you want to be quick, use without bubble wrap. If you want to do it right, don't use any at all. Yeah.
Okay.
And he tests a lot of like the phone and stuff like that, and he tests bubble wrap as well. And almost all the time, the bubble wrap does not protect the artifact or anything.
Okay.
Then
Are
that
there-
one-
Are there any shipping boxes available today that use the kinds of foams that you're talking about?
We haven't really gone, not that we know of, honestly. We kind of looked, not really.
Okay.
So this is kind of a new idea, I guess.
All right, so tell me exactly what's innovative about your box? I'm an archaeologist and I've been using bubble wrap. So you're coming to me and saying, well, I'm not a PhD, so I'm just Mr. Gates. We have something new for you. Tell me what it is.
So differences of this one right here, it uses foam. This one is special because it helps insulate the box,
Okay,
so it,
I like that. That's
can
great.
keep the artifacts.
Cushions the artifact.
So, because there's this thing called carbon-14 dating, and, if you insulate the box, the carbon-14 kind of stays on the artifact, and
Oh,
if you
I didn't know that.
use carbon-14 dating, you can then figure out how old the artifact is.
Sure.
So by insulating it, then you can figure out more accurately how old it is, and then the foam on the inside just helps overall in operating.
Okay.
And is that why you chose to go the route of a sensor, to keep that kind of
So you,
environment?
the sensor, so you know what happened, basically. So if the insulation said didn't work, you could modify your calculations
So you
on
could,
carbon-14.
You could see oh, it's not working, it's very cold now. Then you could what happened, like, if like anything happened to the phone, like there was a hole in it, something like that, if it got too hot, and we might add a accelerometer to see if like it's been, like if it was bumped around.
Excellent, I'm glad you brought that up, that was gonna be my next question. Because this is all about the shock, right?
Yeah.
Cushioning the shock.
Yes.
Now you have a way to prove that it works.
Yeah.
Okay. All right.
That's it for time.
Yeah, we run out of time.
But thank you guys very much.
Yeah.
We appreciate your